In a previous video, I've used one of these relay boards to switch the outputs of a multiplexer so that I can stick a signal through some coils to generate outputs for an LED display. Yes, it was complicated, unnecessarily complicated. It struck me after the event that I could have done away with the multiplexer entirely and used the same relays to create the multiplexer and the switching element for the signal. The way I think I can achieve this is by using a binary decision tree. And if I bring up the circuit, you can see that on the far left of the image we have a sinusoidal signal coming in, and it goes into a relay which is either normally open or normally closed. The state of that relay is controlled by the A signal, which is the most significant bit of my 4-bit signal. The output, or the outputs of the A relay, are then split into 2 relays that are activated by the B signal, so that's the next most significant bit. The outputs of both of those relays, that is both the normally open and the normally closed contacts of both relays, are then fed into 4 more relays that are activated or not by the C signal. And then finally, the outputs of those 4 relays are then fed into 8 relays controlled by the least significant bit, the D signal, the output of which is our 16 different outputs. So here I've got the A, B, C and D relays that can be controlled by these buttons here, A, B, C and D. I've wired up the circuits so that when I press the A, B, C, D buttons, the groups of relays come on and off. At the moment, there's nothing on the input to the common of the A, which is the signal coming in, or will be the signal coming in, and there's nothing on the outputs of the D's, so that's the normally open and normally closed connections, which would represent the 16 outputs of the multiplexer. And the reason why I haven't connected anything up is because I want to meter out all of the D outputs just to make sure that they all go back to the right places. First though, we'll just test to make sure the relays come on when it's powered up. If I press the A button, the A relays come on. If I press the B button, the B relays come on. If I press the C button, the C relays come on. And if I press the D button, all 8 of the D relays come on. So I've got all the right wires connected, just not necessarily in the right order. I'm going to have to rewire this because what I would like to happen is for the topmost point on the D relay here to be 0 and for this point down here to be F. Instead what I've got is 0, 1, 2, 3, 4, 5, 6, 7, etc. I've got to rewire it. While the cabling is now a little less tidy than it was, we do now have a relay board that beeps from 0 to F from top to bottom in the correct order, which makes life a little bit easier. So the next step is to take the entire board and replace out the multiplexer and relay board on the 7-segment display driver and counter circuit. This is the old circuit counting through using the 4060 multiplexer to switch the relays. I'm going to take that off the board, disconnect this relay circuit here, and connect my new relay multiplexer in place of them both. The new relay multiplexer board is now in place, and as you can see, the counter is counting. And the counting is working better than it was before. I finally figured out how to get the lights to light up properly. The problem was, at some point I'd changed the frequency of the sine wave going through the coils, or the cores of the coils, and that sort of detuned the comparator circuits. So I've just bumped the frequency back up, and I think it's about 5 kilohertz now, and it works, as you can see, much better. This is pretty awesome now. Pointless, but awesome. To summarise then, I've taken this block at the bottom, the counter block, and I've extracted the multiplexer from it and incorporated it into the relay section. All I can say really is the reason for doing it ultimately is to simplify the counter section so that it is just the divider. That way in the future, if I decide that I want to replace the divider with some other mechanism for selecting the output, then I can.
全然時々